Hi everyone, how's it going? Today we're going to be talking about the merge sort algorithm, which can sometimes be perceived as a very complicated algorithm. And admittedly, it might be a little bit difficult to understand at the beginning, but once you actually understand what it does at a conceptual level, I think you'll be able to wrap your head around it way more quickly. And so that's what this video is about. So let's dive right into it. The merge sort algorithm is just an algorithm to sort numbers inside an array, right? Um, and so let me just give you an example. Let's just say that we have an array of ages for people, right? Let's say we have someone age 40, someone age 15, someone aged 25, 90, and 34, right? And let's say that we want to organize the numbers inside of this array. So how will we go about this? Well, the way we would go about doing this would be, if we were to use merge sort, we would be splitting this array multiple times. And let me just show you real quick how merge sort works. So I'm just going to paste this array over here, and and you'll see why it's called merge sort at the end. So the first part of the algorithm is splitting the array into multiple halves. So we look for the middle element in the array, and then we divide the array into two halves, right? We say, so we go ahead and split this array, and this is going to be the leftmost array. So this is a subarray. This is the first level of subarrays. We've got 40, 15, 25, and then this is the second, and then this is also like the first level of subarrays, but on the right side. So this is 90 and 34. Then we want to go ahead and further split the subarrays. So we want to keep doing this until we get arrays of length 1, until we get to the very bottom, right? So we want to do, we're going to split this one into two halves again, right? So this is going to be 40 and 15, and this is going to be 25. And over here, we're going to split this one into two one one number arrays. So this is going to be one array, and then this is going to be another array. And so on this side, we've already reached the bottom. We can't keep further dividing it. But on this side, we still got one more level to go on the left sub half. So we can go ahead and divide it into um, two one number arrays. All right, so now we've reached the bottom, right? We have arrays of length 1. They just contain one number in them. And now that we've divided them, this is where we want to start merging them once again. So you see these halves that we see over here, the right half and the left half, we can start merging them again. And when we merge them, we want to make sure that they're merged in a way that is sorted. So this is where the name comes from. We're merging the subhalves and sorting them at the same time. Um, and so let's go ahead and see how this would work. So we merge 15 and 40, but this time we want to sort them. So this will return 15 and 40. You see, we merged them, and now we have a resulting array that is sorted. This subhalf is now sorted. Now we can delete this. Now this subhalf needs to be merged with this one. So how can we merge them? Well, what would the order be? The order would be, we would have 15, then we would have 25, and then we would have 40, and we can get rid of this one. Right? Sorry about that. And then the same is the case with the right side, right? On the right side, we want to merge these two arrays that have one number in them in a way that renders them sorted. So that would be, you would have 34 and then 90, right? And now we're back at the top, almost back at the top again. We want to merge the two subhalves that we had. As you can see, now these subhalves are themselves sorted. We just need to make sure that the resulting array is itself sorted. Um, so we can go ahead and merge these two, and that will give us 15, 25, 34, um, 40, and 90. See, is that it? 15, 25, 34, 40, and 90. Yeah, that's right. So we essentially break down. I hope that made sense, but we're essentially breaking down the array and then building it back up. And we're breaking down the problem into sort of like smaller problems, sort of like just smaller sub problems that will allow us to make the problem easier to solve, right, or easier to understand. And so now we're going to go ahead and carry out the implementation. So the implementation is as follows. We define a function called MergeSort, which takes an array, and then we want to remember we're going to be using recursion. So MergeSort is going to be calling itself, um, and so we want to have a base case, and the base case is going to be if the array length is equal to 1, then we want to return the array. So remember when we were like sort of like breaking down the tree and we got to the bottom level where each array had um, a length of 1? Well, this is the base case where each array has a length of 1. Then the next thing we want to do is, well, if the array does not have a length of 1 yet, then we want to find the middle element. And the way we do that is by first dividing the array length by 2, and then rounding down with math.floor. And then we're going to split the array. Remember how we're splitting the arrays into halves? We want to split the array, right? So we want to determine, well, this is going to be the left array. And the left array is going to be everything to the left of the middle number. And the right array is going to be everything, you guessed it, to the right of the middle number. And now this is where we want to go ahead. So this helps us break down the array, right? But the part where we merge the array needs to be carried out by a different function. So we're going to go ahead and create a helper function called merge. And merge will take in two arrays. So this will be the left array, the right array. And the first thing that we want to do with merge is we want to define a final array. So we want to define a final array. And then we want to define indexes for each array. You will see just in a bit. Just have patience if you can. So we'll define two indexes. One for the left array. It's going to be 0. And then one for the right right array, which is also going to be 0. And we're going to say the following. We want to create a while loop that keeps running as long as both indexes are less than the length of their respective arrays. So if both left index is less than left array dot length, and both conditions need to be met, and right index is less than right array dot length, then we want to go ahead and evaluate the following conditions. We want to first check. This is the merging part, remember. So this is the part where we have the arrays are split. So let me just show you with a different array. Let's just say we have 25. Let's just say 40 and 25, and then 19 and 23. So this is the part where we're merging these two arrays. So in order to merge them and have a result that gives us a sorted array, we need to evaluate these conditions over here. This is what's going to allow us to have an array that is sorted once we merge the two halves. So we need to figure out, okay, what's greater, 19 or 40? Okay, so 19 is greater than 40, right, etc. So we're going to push 19 over here, and then we're going to figure out, well, which one is greater, 23 or 40? Okay, 23, right? And so this whole process of like evaluating the numbers inside of the subhalves and figuring out which one is going to be pushed first into the array that's at the top level, that's what's included in this logic over here. So you'll see as follows. So we're going to figure out, well, if the left current element in the left array, so essentially if the first element of the left array in this point, if it's the first call, is less than than the first element in the right array, remember, because we're just starting off with an index of 0, we're going to go ahead and push this one to the final array at the end. This is the one that we're going to be returning at the end. So this is going to be final array dot push left array left index, right? And then we want to update the left index variable so that it continues to move, right? And so now the pointer is not going to be in the 0th element, it's going to be in the first element. Same applies in the alternative condition, right? If the element in the right array is smaller, then we want to go ahead and push that one first. So right array, right index, and then we want to go ahead and update the index. And this is going to continue happening until we're essentially done with one of the arrays, until we've pushed all of the numbers inside one of the arrays. Then this condition is no longer going to be met. And in that case, what we want to do is we want to return a concatenation of the final array, which is going to contain the numbers that we've pushed so far. Then we want to push in we want to use the spread operator with 3 dots. So this just gives you the numbers in an array. So we want to get the numbers that are located after wherever the index is located in the left array. So the index worked up till a certain point, and we want to concatenate the numbers that are after that index right now. I hope that makes sense. And then we want to concatenate again with the elements that are left in the right array, right? Let me see if that makes sense. All right, and so this is working fine. We're going to go ahead and check this, of course. And just something that I would like to mention is the fact that one of these two arrays at this point, you see how we're concatenating what remains of the two arrays. In one of the instances, this is actually going to return nothing, because remember, if this condition is no longer met, it means that we already went through all the numbers in one of the arrays. So this, whether it's the right one or the left one, the one that finished first is essentially going to contain nothing here. So now we're just going to go ahead and give it a try and see if it works. What's up, everybody? So there's one thing that I forgot to include in the MergeSort algorithm, which was, now that we've written the helper function, we actually want to go ahead and include it in the MergeSort function over here. So the sort function is going to be returning the merge function, and as the left and right arrays, remember it's taking left and right array, a left and a right array, we're going to be passing in the merge sort of the left array and the merge sort of the right array. Remember, because this is going to allow us to keep splitting the array in half until it reaches 1. If that makes sense. And now we can go ahead and test it, right? So let's just say we can actually try with this array over here. Let me just paste this over here. And let's console.log the result of passing in this array to MergeSort. You see, it's not sorted at the moment. Let's see what happens when we run the script. looks sorted to me now. We can try something different, right? We can try 5 for 120, right? And then we run it again. 4, 5, 20, and 100. So that seems to be working fine. I hope you guys enjoyed the video, and if you have any questions or comments, please let me know in the comment section, and like and subscribe if you enjoyed the video. Have a great one.